Hi friends, we're going to start with the chapter called construction. However, construction, and there is one more chapter called loci or loci or loci. Anything you pronounce is the same thing. Come on. Now these are the two chapters which are actually separate chapters in maths textbook. But their concepts are very much interconnected, very much correlated to each other. So I am going to function them, take them, merge them together. So I'm going to teach two chapters simultaneously, and trust me, you're going to enjoy it. Now, there are many pointers, there are many, rules for different sums. If I tell you all the rules and regulations right now at the start, it is going to be very monotonous, it's going to be boring. Second, you will not even remember many of them. So what I suggest for these two chapters to you all is, we'll take a sum, we'll see the concept based on that sum. Yeah. Then we'll take another sum and we'll see the other concept. So what we're going to do is, we'll take a question, we'll write a note like a highlighter, right? So any sum which comes of that same variety, you will definitely be able to crack that sum easily. There are very few sums in construction, but loci, sky is the limit. Sky is the limit, because every sum is a different sum in loci. We need to remember few rules in order to solve the questions. And if we stick to those rules, trust me, any sum which you will encounter is going to be a successful encounter. Yeah. So let's begin with the first question on construction. Now, again, if I'm writing construction and loci together, the weightage of this the two chapters together, approximately 3 questions to 4 questions I can encounter in the board exam, worth 9 to 12 marks. Now this can change. Sometimes there were 5 questions in 1 year's board paper. Sometimes there were only 2 questions. So this is not fixed, but on an average, 3 questions is what I'm counting on an average, right? So I begin with my first question on construction chapter for y'all, right? The question is, construct a tangent to a given circle whose radius is 4 centimeter, where the point at which the tangent should be drawn is on the circumference of the circle. So you have seen the question which is out here. Now remember one thing. Construct a tangent at a point on the circle of radius 4 centimeter. So first things first, what you're going to do is, you're going to draw a circle. You're going to draw a circle of radius 4 centimeter. Let's begin, students. So first, I'm going to construct a circle. Look, I'm doing a freehand diagram in this chapter, but I'm going to tell you exactly where to place the compass, where to place the scale, where to place the, the tip of the rounder. Everything I'm going to tell you. So let's start with the start. I keep the tip of my rounder. Rounder is a compass, huh? Please. Okay. So I'm going to place the tip of my rounder at this point. Let me call this point as O. Stretch the rounder by 4 centimeter radius. Yeah, that's going to be the radius of the circle. And you draw a circle. So I can say the radius is 4 centimeter. Fine. Now, after this, you take a scale, a ruler, and you just, from the center, you draw a straight line. Just extend it, guys. Just random extension. Okay. This point, you call it as P. And definitely, please write down the data. 4 centimeter. At this point P is on the circumference of the circle. I want to draw a tangent at this point. To draw a tangent, you need to draw a 90 degrees. So keep your rounder, mark my words, start doing what I'm saying. Come on, take a pen, pencil, paper, everything. Keep it ready now. Now, come on. And what I'm saying, you do it. You do this with me. You perform these sums with me now. Okay. So keep the rounder, the tip of the rounder at P. Okay. Okay. Stretch the rounder lump sum, okay, to a certain extent and cut two arcs on either side of P. Stretch the rounder, lump sum, your wish, cut arc on the right and same cut arc on the left. Okay, now after this, keep the tip of your rounder, the point, that pointed thing, yeah, of your rounder at one of this arc, and from this point, stretch it lump sum, approximate. Stretch it, cut an arc up, cut an arc down. And using the same dimensions, keep the tip of the rounder out here, cut an arc up, cut an arc down. And all you do is just join it. Yeah, just join it. And that's going to be the tangent at point P. You name these arcs. Let me call this arcs as A and B. Yeah, A and B, or you can call it as X and Y. That's it. Nothing more to be done. So this is called to draw a tangent at a point on the circumference of a circle. So the point is on the circle. So if I write the basics, can I say the point is on the circle? This is category 1 sum, right? Okay. So can I come to a conclusion? When a point is on the circle, you can only draw one tangent. So one and only one tangent can be drawn when a point lies on the circumference of a circle. Let's start with my second question for you all. Alright, second question. The question is, draw a circle of radius 3 cm, mark a point P which is at a distance of 5 cm from the center of the circle. Okay, and draw two tangents PA and PB to the same circle. Measure the length of each tangent. So the radius is 3 and the point is 5. Step 1, take a rounder. Take a point where the tip of the rounder should be placed. Right. From this, stretch up till 3 cm on the scale. Take a rounder, stretch it to 3 cm, draw a circle. So if I stretch it and I draw a circle, radius of the circle is 3 cm. Perfect. Now, from this point, at a distance of 5 cm, you just stretch a line. And this point is P. So this OP distance is going to be 5 cm. Fine, I'll remember that. From this external point, now out here in this diagram, the point was on the circumference. Out here, the point lies outside. From exterior point, I can draw two tangents this way. Now, how to do that? Step number 1. Step number 1. For this OP, draw a perpendicular bisector. How to draw a perpendicular bisector? Come on. Keep the rounder tip at point O. Stretch more than half on the rounder. Lump sum, approx. Stretch the rounder up till more than half. Cut an arc up. Cut an arc down. With the same dimension, take the tip of the rounder at P now. First it was at O. More than half, cut an arc up, cut an arc down. With the same dimensions from P, cut an arc up, yeah, cut an arc down. Join it. Let's say this point is M and this point is N. This is actually a perpendicular bisector. What do you mean by a perpendicular bisector? It bisects two equal parts and it is even 90 degrees. Right, this is a perpendicular bisector. Now, keep the tip of your compass, your rounder, at this point, the perpendicular bisector point. Yeah, at this point, stretch the rounder up till P or O, that is going to be the radius. Keep the rounder tip at this point, stretch it up till O, and just make a circle. Make a circle. Yeah, that's a circle for y'all. Now, where the two circles, where the green and the blue circles intersect, they intersect at two portions, 2 points, out here and out here. Join. This is one of my tangent, and this is my other tangent. They meet at point A and at point B respectively. This is how you draw, and then you can write this down, that this was 5 centimeter and the radius was 3 centimeter. Now, in the board exam, you need to even draw a rough diagram. Remember, I always do this thing. I first draw a fair diagram and then I make a replica of this at the top, a small one. Now remember, the rough diagram also should be drawn very neat. It shouldn't be your rough diagram. Yeah, I know your rough diagram, horrible, utter shit. No, it's not that. You need to draw the same thing up by just looking at it, but with a coin. Yeah, coin is a miniature figure, na? Yeah, 1 rupee or 2 rupee coin, you can do that. Okay, so first always prefer drawing the main figure followed by the rough diagram. So if I happen to name the generalized form of this, I'll say the point is outside the circle. So please tell me one thing. When the point is on the circle, how many tangents can be drawn? 1. But if a point is outside the circle, to the same circle, how many tangents can be drawn? 2. But if a point is inside the circle, you take a point inside the circle, you can't draw a tangent. Nonsense. You can't draw a tangent. So when a point is outside, 2 tangents can be drawn. When a point is inside, no tangent can be drawn. And when a point is on the circumference, 1 tangent can be drawn. Right, guys? So these were my 2 questions till now. Go through them. If you have skipped out on anything, pause the video. Now you have that comfort zone. Yeah, you have that ability to pause the video, go back, listen to what I spoke, and definitely do the construction steps. Third, now it's a new variety of question. Class, I love this sum. The question is, draw a circle of radius 4.5 centimeter and draw tangents to the circle such that the angle between the 2 tangents is 60 degrees. Now look at the geometric solving behind this sum. Okay, wonderful question. Listen, I will draw a rough analysis first. I'll have to, else it will be a flop show. See the thought behind it. Now this is my third question. I'm just drawing a rough figure. Look, I'll just, there is a circle, students. Yeah. And from an external, the radius of the circle is 4.5. Okay. From an external point where even I don't know. Oh God. So if this is the center, in the previous sum I had been given that the point was at a distance of 5 centimeter. And it was given now. 5 centimeter. But now the problem is, I don't know where will the point be. I just have to draw tangents. But when I draw 2 tangents, this angle is 60 degree. That is given to me. Okay. So angle between the 2 tangents is given to me as 60. Now always remember, this is what I'm going to do now is a concept. Radius is always perpendicular to the tangent. Radius and tangents are always perpendicular to each other. So if I do some extra geometry, behind this sum? Check. I'll draw a radius. Aha! Radius and tangents are perpendicular. Awesome. Let this central angle be x. Okay, sounds good. Isn't this, have they given a name of, no, they've said nothing. Let me call this point as P, A, O and B. I can use the geometry involved behind this. Can I say in a quadrilateral OAPB, yep, sum of all the four angles, the interior angles is 360. So I can say x plus 90 plus 90 plus 60 is 360. Some measure of all angles of a quadrilateral, yep, is 360. So I get x as, on solving this, you get 180 minus 60, 120 degrees. So I very well know one thing, that between the two radii, radius, the angle needs to be drawn is 120. So automatically this angle will come out to be 60. So look at my chart. The start is going to be a circle of radius 4.5. Okay. Circle of radius 4.5. Yeah, center out here. I will randomly draw, okay, a radius with some extension. Fine, this is my radius. And definitely it has cut. Okay. Now from this as the center, look, I took a scale, a ruler, I just drew it. No thought involved out here, nothing. Let me call this as O. Yep. Let me call this as A. Something like this, OA. Now make a 120 degrees out here. How to make a 120? Keep the point of your rounder at O. Okay, make an arc. Taking this as the same distance. Listen, I drew an arc. Now taking the same distance, you're not going to change this dimension. From this point, cut an arc. And from this point, cut an arc. Draw. Look what I did. Check. First, I just drew a line. I just randomly cut an arc, but with the same dimension, cut an arc out here, and from this point, cut an arc out here. So this is 120 degrees. And obviously now what I'm going to do is, I'm going to draw two tangents. Okay. Let this point is B. Now I have to draw a tangent at A and the other tangent at B. Isn't this like my first sum? Oh, the first sum was draw a tangent to the circle where the point lies on the circumference. The point is on the circumference. Check na. Isn't this point on the circumference? Isn't this point? Yup. It's on the circumference of the circle. So how to do it? Simple. This is the first sum now. First sum. Take the rounder of your compass out here. Keep it out here. Cut an arc on either sides. Same. Cut an arc on either sides. From this point, stretch, random, stretch the compass. Cut an arc up and down. And from here, cut an arc up and down. Similarly, from this, cut an arc up and down. From this point, cut an arc up and down. You just join it. Yeah. And join this. Yeah, with a straight line. And you can extend it. And where they meet now, guys, this, trust me, automatically, this is going to be 60 degrees. And obviously the radius and the tangent have to be perpendicular. So you can call this as 90, you can call this as 90 and 120 degrees. They are the radii of the same circle. They have to be equal. Oh, wonderful question. So I hope you have understood this sum. This was your third question, in which the angle between the two tangents externally where they meet is given. Through geometry, I started with 120, and this is the working of geometry. Right, let's go on with the fourth question. Using ruler and compass only, draw an equilateral triangle of side 4.5 centimeter. Draw a circumscribed circle. Now, a new concept comes into picture. Circum means outer. So, in the fourth question, we need to draw a circumscribed circle. And always remember, whenever you come across the word circumscribe or circumcenter or circumradius, circum, we need to focus on perpendicular bisectors. So henceforth, whenever there is a word circumscribed circle, remember it is always connected, associated with perpendicular bisector. What do you mean by that? Wait na, I'm coming na, where have I taught you? Hold na. So now first what I'm going to do is, let's draw an equilateral triangle of side 4.5. Let's begin the show. So first, I draw one of the sides. Let's say this is BC. It's 4.5. Take the compass. Keep the tip of your compass, your rounder at B. Stretch 4.5, yes, on the scale. Cut an arc. From C, do the same. Cut an arc. Join. So this is your triangle, your equilateral triangle ABC. Fine. 4.5, 4.5, 4.5. Lovely. You have to draw a circumscribed circle. That means a circle should pass through the vertices of a triangle. Outer circle is what I want. I have written perpendicular bisector. See the significance. Take any two sides. Any two sides. I will take the longer sides. In this, all sides are equal, so it's okay. Let's take BC. I'm going to draw perpendicular bisector to two sides. First, keep the rounder, the compass, the point at B. Stretch the pencil more than half, approximate, lump sum. Cut an arc up, cut an arc down. Cut an arc up, cut an arc down. So it's going to be somewhat like this. Here and here. And from C, with the same dimension, cut an arc up, cut an arc down, and draw a line. This is perpendicular bisector, one of them. Okay, do the same process for either AB or AC, whichever you like. Let me make it for AC. From C, stretch, keep the pointer, the point of your rounder at C. Stretch more than half, approx. Cut an arc up on this side and cut an arc down on the other side. From A again, cut an arc up, cut an arc down. This is my second arc. Okay, the two of them, this is again a perpendicular bisector. 90 degrees and a bisector. Both of them meet at a point. Let this point be, let the point of intersection be O. Take O as my center. Keep the rounder tip. Keep the tip of the compass, the rounder at O. Stretch up till A. Stretch that pencil part up till A. Draw a circle. Okay, you're going to have something like this. You'll get a circle like this. So this is going to be a circumscribed circle. So what is the significance, the importance of a perpendicular bisector? That whenever you want to draw an outer circle to a triangle, what do we make? We make perpendicular bisectors. We make perpendicular bisectors to any two sides. Where they meet, take that point. take the rounder, the tip at that point, stretch it to the vertex, pull in a circle. That's your answer. Okay, I'm again saying I'm not drawing a rough diagram. You need to do that by yourself. Okay, so guys, we have seen 4 questions and all 4 of them were different. Question 1, when a point is on the circumference, how to draw a tangent. Second, point is outside, how to draw tangents, 2 tangents. Third, point is outside. I don't know where the point is, but I know the angle between them. Through geometry, how to solve this sum. And fourth, circumscribed circle, right? Go through them. The 5th question. Yeah, in the 4th question, which I did now, they are also asking me find the radius of the circle. I guess you'll be able to measure that with a scale, right? Please, I've drawn a freehand diagram and this is natural. I'm not preparing and coming. I'm not here to just give you that monotonous, the startup, like I have prepared and come and I'm teaching you what I have prepared. No, this is natural. And of course, you can definitely measure it. Yeah, you measure it with a ruler, the radius of the circle. All right, 5th question. It's a new question again. The question is, using ruler and compass only. Okay, fine. Why are they telling me? I'm doing that only. Draw an equilateral triangle of side 5 centimeter and draw an inscribed circle. Inscribed circle. Okay, I'll write down the header. 5th. Okay, guys, for an inscribed circle, I will be taking into consideration angle bisector. What did I say? Angle bisector. These are the 2 words, important. Come on, students. For a circumscribed circle, it's a perpendicular bisector. For an inscribed circle, we're going to focus on angle bisectors. Very important. First thing, they're asking me to draw an equilateral triangle of side 5 centimeter. Let's do that. Let's respect their decision. So first thing, let's say this is your BC side 5. Keep the tip of your rounder at B stretched up till 5 centimeter. Cut an arc. From C, do the same thing. Cut an arc. Join. Join. That's your ABC, which is an equilateral triangle. I need to draw an incircle inside. What you do is, you draw angle bisectors of any 2 angles. You drew perpendicular bisectors of 2 sides. Now, angle bisectors of 2 angles. Yep. So first thing, let me take the base as my angle bisectors. That's easy to do. Keep the tip of your compass at B. Just lump sum, you stretch it, cut an arc. Do the same at C. So this is called angle bisector. Okay. Now, keep the tip of your compass again at this point, Stretch it approx your wish. Don't go outside the diagram. Stretch it approx, cut an arc. And from this point, same dimensions, cut an arc. That's your one of the angle bisectors. Second, from this point again, this, stretch the compass rounder, keep the rounder tip out here, cut an arc, and from this point, cut an arc. Yeah, perfect. Somewhere like this. Okay, now what you do is, ideally, it should meet somewhere in between, somewhere out here, according to my experience. Somewhere just underneath A, somewhere out here, but it's okay. You have understood what I've done. Fine. Now what you do is, it's not over. Listen, take this point as O. I'm going slow. Keep the pointed tip of the rounder at O. Stretch the rounder approximately and draw a smiley. Your smiley. From here, you cut a smiley out here. That means one cut out here, one cut out here. Arey, if I join this, doesn't this become a smiley? That's what I'm saying. Keep the tip of the rounder out here, stretch it, approx. It's everything is approx in life only. Yeah, stretch it, draw a smiley. 2 arcs cut. And from this point, again, cut an arc, from this point, cut an arc. Join. Okay, this is going to be perpendicular. This is the method of making a perpendicular. So again, I draw a triangle, cut an arc at B, cut an arc at C. From the two intersection points, cut arcs. From C to intersection points, cut arcs. Where they meet, keep the tip of the rounder out there, stretch it approx, draw a smiley. And from these 2 points, again draw 2 arcs, join it. Final step, keep the point of the rounder again at the same point O, stretch it up till this point, that is the radius of the circle, this much, and just draw a circle. Yes, the circle will be joining the sides of the triangle. The circle should join the sides of the triangle. Now there is some cheating involved out here. First, what you do is when you draw this circle, and if you find that the circle, just like mine, it's a freehand diagram, that the circle is slightly going outside the triangle. The circle is not touching exactly the 3 sides, is slightly going outside the triangle. What you do is, you thoda na shift the point here and there. Shift the rounder tip. I know you are like saintly person, yaar. Oh yeah. What saintly person? Oh, be sent in some other direction. Out here, get the answer correct. Shift the rounder point a bit here and there, and just check. First, check with a pencil whether it's touching all the 3 sides or no. If it's yes, if it's touching all the 3 sides, what you do is, at that point, you take the point and then draw a circle. Yeah, because the reason is, because of human errors, because of the thickness of the pencil, the lead, there is a chance that the point might go 0.1 or half centimeter here and there. As a result of which, 100% accuracy may not be, attained. So in that case, don't sit and resolve this because we don't have time. We have only 5 minutes and 30 seconds to draw this diagram in the board exam. We don't have all day long, please. So what you do is shift the pencil, shift that pointer of the compass a bit here and there and check. First check, just a normal cross check, whether the pencil touches the 3 sides of the triangle. And then you fix up that point, draw a circle. Fine, perfect. That's your 5th question. Okay, the question, again a new variety. Look, every question is new. 6th, construct a triangle ABC in which side AB is 5, BC is 6.8 and the median AD 4.4. Draw in circle to this triangle. Serious, yeah. Like, check. First, AB is 5, the 6th question. Then I suspect BC 6.8. And AD, that is the median, that is D is the midpoint, is 4.4. If AD is the median, then D is the midpoint of BC. Let's see how to do this. Let's first draw BC as the base 6.8. BC is the base 6.8. AB is 5. Now I know A is somewhere out here, up. From B, you can cut an arc 5 centimeter in length. Keep the rounder tip at B, stretch it 5 centimeter, cut an arc somewhere out here. So A will be somewhere on this arc, where even I don't know. Now I know that A will be somewhere out here. From A, I'm going to draw a median, that's AD, which is 4.4. Now do you know median? Median means that line cuts BC at the midpoint. That line cuts BC at the midpoint. So first draw the midpoint of BC. You can't say, sir, this is 6.8 na. Divide by 2, 3.4. At 3.4, can we make a midpoint? No. To get a midpoint, I want you to draw a perpendicular bisector. I need that. So from B, keep the rounder tip at B. More than half, lump sum, cut an arc up, cut an arc down. And from C, same, cut an arc up, cut an arc down. This is not a part of the sum. I'm just finding out the midpoint. This is your midpoint D. AD is 4.4. From D, keep the rounder tip at D, stretch a 4.4, cut an arc. That's your point A. Join. This is AB. This is AC. Right? And this is the median AD 4.4. After this, draw an incircle, they are saying. Incircle, same as the previous sum. Take the point B, cut an arc. Take the point C, cut an arc. From this point, take the rounder. Keep the tip of the rounder at this point. Cut an arc. From here, cut an arc. Correct. Out here again. Keep the rounder tip out here, cut an arc, lump sum. From here, cut an arc. Alright. And where they meet, you draw a smiley. At this point of intersection, let this be O. Keep the rounder tip at O. Stretch it to the base. Draw a smiley. And again, from these two smiley points, cut an arc, cut an arc. Join. This is a perpendicular. And finally, you take this much as the radius, and draw an incircle. Somewhat like this. That's your incircle. Don't shade so many times. Just a single circular line. It's fine. So this is your incircle. A wonderful question where, can I say, a median was involved in the sum. So we do a triangle in a very different manner. Sixth question. Let's go on with seventh. Draw a line AB 5 cm. Mark a point C on AB such that line AC is 3 cm. Fine. Using a ruler and compass, a circle of radius 2.5 cm is passing through A and C. Oh God. Okay. Construct two tangents to the circle from an external point B. Oh God. Oh man. Look at the thought. Look at the class of the sum. Superb sum. Superb sum. Seventh. This is not that easy to explain. Check. First, draw a line AB as 5. Okay. That's the line AB as 5. Take a point C on this AB such that AC is 3 cm. Yeah, somewhere. You stretch, take the rounder tip out here, stretch a 3 cm, cut an arc. See, this is 3, this is 2, the entire is 5. Okay. Now, they are saying that a circle of radius 2.5 cm passing through A and C. That means there will be a center somewhere out here, so that if I join that center with C and that center with A and I draw a circle, the radius of the circle should be 2.5 and the circle should pass through A and C. Okay, for that what you do is you draw a perpendicular bisector of AC. From C, more than half, cut an arc up, cut an arc down. And from A with the same dimensions, cut an arc up, cut an arc down. This is your perpendicular bisector. Now, from this point, you can cut a 2.5 out here, and from the same you can cut a 2.5 on this line. That means this is actually gonna be your center of the circle. So what you did was, from O, first I took C as my tip of the rounder. Tip of the rounder is C, stretch a 2.5 centimeter, cut on this perpendicular bisector. Similarly, stretch from A, stretch, keep the rounder tip out here, stretch a 2.5, cut an arc on the same perpendicular bisector. They meet, that's the center of my circle. Yeah. So final verdict, take OC as the radius 2.5, draw a circle. Draw a circle. Yeah, that should be the circle. Somewhat like that. Perfect. Now, can I say that this is 2.5? Even this is 2.5. And can I say my circle, the pink circle, has radius 2.5 and it is passing through A and C both. Perfect. And now what you do is, I have the center O. You join OB. Join OB. And you need to draw from B the two tangents. And that's my second question. From an external point to the circle, I am going to draw two tangents. For that, what you do is, come on students, more than half, cut an arc up, cut an arc down, cut an arc up, cut an arc down. And take this as the pointer, stretch the tip of the rounder till O, draw another circle. And where the two circles meet, this point and this point, let's say M and N, just join. So 1, 2. These are my two tangents. They are going to meet out here, not here. Come on. Okay, so look at the complexity of the diagram. Just look at that. I'm repeating what I did. First, I drew a line AB 5 centimeter. Second, from A, I stretch 3 centimeter at C, cut an arc. Now, I have been given a condition. I need to draw a circle passing through C and A. Circle should pass through C and A. That means A and C should lie on the circumference of circle. Also, the radius of the circle should be 2.5. So I started this way. I first made a perpendicular bisector of AC. That's this blue dotted line. Okay. I got the blue line, the perpendicular bisector. From C and from A, I took 2.5. I went backwards. I took 2.5 and cut an arc, which is nothing but the center of the circle O. And keeping the rounder tip, the tip of the compass at O, stretch 2.5 centimeter radius, draw a circle. It will definitely pass through A and C. Once I get the circle, the pink circle out here, I have to draw two tangents from B to this pink circle. What I did was I started the same as my second question. I joined OB. From the center, I joined the external point. I drew a perpendicular bisector, more than half cut an arc. Take this, let's call this as S, as the center, and stretch it through the compass till O. Draw a circle. Where the two circles intersect, from B, stretch the two tangents. Those are my tangents. Alright guys, next question. Sum number 8. Now we have seen 7 different categories of sum. 7 questions I've taken for you all different. So it becomes a bit difficult to digest, nah? So now let me take one sum as one of the sums which you've done prior, but with a few complications. Yeah. So 8th question. Draw a circle of radius 3.5 centimeter. Mark a point P outside the circle which is at a distance of 6 centimeter from the center. Construct two tangents and jot down the length of the two tangents. So this is same as the second question. But yeah, such sums are definitely very important, okay, from the board exam point of view. So let me take one more question like this. Simple. So same as second question, but yeah, come on, let me just take time to digest the 7 different varieties of sums. So just like a, a surprise visit of the second question back as the 8th question. All right, so first thing is I'm going to draw the radius of the circle as 3.5. So the center of the circle, taking the tip out here of the compass, you draw a circle of radius 3.5. And now an external point is 6 centimeter from the center O. So from the center O, students, you just draw a line here, 6 centimeter. Yeah, this is 6. Let this external point be P. From that point P, I need to draw two tangents. We have done this sum. Come on. So take the tip of your rounder at O, stretch it more than half, cut an arc up, cut an arc down. From P, taking the same dimensions, cut an arc up, cut an arc down. So I have, just draw this. Yeah, this is like your point M and N. Now taking this point is actually the center point, the midpoint of OP. It's the midpoint of OP. Yes, of course it is. Taking this as the center, keep the rounder, the compass tip out here at this point, let's say L. Stretch your pencil up till O and draw a circle. Now obviously that becomes the radius, I suspect. So I drew a circle where the two circles, the pink and the blue circles intersect. Yeah, that's going to be my point of concern, A and B. And just join. AP, extend it. Join BP. Yeah, it's joined it, come on. And obviously, these are my two tangents. And they have to be equidistant. So length of AP should be equal to length of BP. You can calculate it by yourself with the help of a scale. You'll get the answer. Right. Talking about my next question. Yeah, sum number 9th. It's different. The question is, construct a regular hexagon. Hexagon. From triangle, we are jumping to a hexagon. Okay. Of side 4 centimeter. Construct a circle containing circumscribing the hexagon. Circumscribe means an external circle. Alright, so let's begin the show. We have the side of a hexagon as 4 centimeter. So first what you do is you draw the base, the side as 4. Let's call this as AB. This is 4 centimeter. You need to draw 6-sided figure. Now, if I am like, wow, a very nice, decent student, very obedient, very sincere, doing no wrong on this earth. If I'm going to do this, it will be a flop show. What I'll do is, I'll draw hexagon. I'll draw 120 degrees. You know how to draw 120. You keep the tip of the rounder out here, stretch it, lump sum, cut an arc, take the same dimension, cut an arc, 120. Same 120. Yeah. Cut it at 4 because 4 centimeter hexagon all sides. 4. Again you draw 120. The chances of getting the right answer at the end are very minimal. So if you do the regular method, I'll show you the regular method. Don't do that in exam. Do cheating, which I'll show you out here. Because through the cheating method, you will get the answer fast and accurate. But no cheating. We'll do regular method. See the regular method. So first, take the rounder tip at B, compass, draw an arc. Similarly from A, draw an arc. Take the same dimension, cut an arc. Take the same dimension, keep the point out here, cut an arc. Extend. Alright. I'm going to cut 4 centimeter. So this is going to be A, B, C. This I'll name it later. At C again you draw a 120 degrees. Cut an arc from here, cut an arc from here, cut an arc. Similarly, draw 120 out here. From here, cut an arc, from here, cut an arc. Right? Perfect. Again, cut a 4 centimeter, cut a 4 centimeter. Perfect. Join it. So A, B, C, D, E, and this is going to be F. This is your hexagon. So 120 degrees, basically you need to make it 4 times. If you are very accurate, you're going to get the answer, the exact answer. Of course, yes. Goes without saying. Alright, so once my hexagon, a 6-sided figure is ready, what you do is draw a circumscribed circle. Circumcircle. Now students, remember one thing. Time and again I have told you, when this word circum comes, you need to draw perpendicular bisector. I have done this. Some number, I guess, 4th or 5th. Yeah, please go through it now. When the word circum comes, we are going to be interested in perpendicular bisector. Take any 2 sides. Your wish, your diagram, your pen, do what you want. Take any 2 sides, draw a perpendicular bisector. So taking the point A, more than half, cut an arc up, cut an arc down. From the B with the same dimensions, cut an arc up, cut an arc down. Join. Yeah, join it. That's one of the line, one of the perpendicular bisector. Again, you can draw a perpendicular bisector of CD or BC, your wish. Okay, so come on, from C, cut an arc, up and down. From D, cut an arc, up and down. Join. It's a perpendicular bisector. Now where they meet, this is the point of intersection. That's your point O. From here, keep the rounder tip out here, stretch it up till any one of the vertex, stretch it and just draw a circle. That's your circumcircle. Okay, have you understood? So what I did was, if I do this diagram very sincerely, right, a line of 4, 120 degrees, cut an arc at 4, from these 2 pointers, F and C, more 120, get them up, cut them at 4, join it. then draw a perpendicular bisector of any two sides, you get the answer. Now this was a very foolproof method. If I work with the cheating method, check what the cheating method is. If you have to draw a hexagon of side 4, if you have to draw a hexagon of side 4 centimeter, first draw a circle straight away of radius 4. So I am drawing a circle straight away of radius 4 centimeter, where this is the center of the circle. Okay, take a point, a random point. Let me call this point as A. Through A, keep the tip of the rounder at A, take 4 centimeter, start cutting very light arcs. From A, cut 4 centimeter. From B, cut 4 centimeter. From C, cut 4 centimeter. From D, cut 4 centimeter. From E, cut 4 centimeter. And there, back 4 centimeter. So 4 arcs, you cut it of 4 centimeter length each. Join them. Just join it. I am ready with my hexagon. And now the teacher will feel he's cheated here. He's cheated. Sure. So what you do is, just for decoration, show off, you draw 120. Oh man, awesome. 120 when you draw, come on, you have to draw 120. You know, I just taught you how to draw 120. Okay, it will be out here only. You do 4 120s. Just extend this now for just like meticulous work. Oh my God, something like this. Oh, awesome. And you draw. Now you already have made a circle. You have done it. Your answer, your figure is over, completed. But we need to do the decorations for our respective teachers to know that no, we've done this seriously. We've done a job. Okay. Look, now I'm sorry about this, but most of the teachers might not like what I'm doing. But listen, teachers, with all due respect to your hard work, your efforts, I'm not going against that. I have taught the actual method to the students, but I want my students and even your students in that case to get marks. Because yes, our system of education needs marks. We know that. We both know that. So it's not an improper education which I'm imparting. No. I have taught them the right method. It's there. The actual method. It's there. Let them follow this. Students, follow this. If you don't get an answer by any chance, you may switch over to this. I have given you an altar. So it's okay. Teachers, please don't take me in the wrong sense. Because I know after me doing this, most of the teachers might be outrageous. No hurting your egos, all my bad. But I'm teaching them both the methods to my kids, please. Okay, please don't take me wrong. So out here, it's not over, students. It's not over. Listen, you take more than half, you cut an arc up, cut an arc down. Yeah, the perpendicular bisector. And again, from any one of the sides, cut an arc up and cut an arc down from A and B. Yeah, somewhat like this. And definitely this is your center O. And you just mention 120 degrees. This is a faster way of solving the question and getting a very much precise. Precision is more in this. The accuracy is more in this. But this is the actual method. Okay, so we drew a circumcircle to a regular hexagon. This is again method 1, the actual method, and method 2, a bit faster trick shortcut method. Now for a regular hexagon, we are going to draw an in-circle. Inscribed, not circumscribed, inscribed. Okay, so let's see how do you do this. First thing, you draw a hexagon in a same manner, the particular manner, yeah, the proper way. So 10th question, the question is, draw an inscribing circle to a regular hexagon of side 5.8 centimeter. Fine, students, draw side 5.8, AB. Again, draw a regular hexagon, 120 degrees. Come on, 120. Keep the point at B, cut an arc, take the same dimension, keep the point, the round at the tip of the compass out here, cut an arc, and from here, cut an arc. Somewhat out here. So 120. From here, cut a 5.8. 5.8. Similarly, cut an arc from here, and keep the rounder out here, cut an arc. Okay, again, cut 5.8. Draw 120 at these two positions. Rounder out here, draw a circle. From here, cut an arc. From here, cut an arc. Keep the tip of the rounder out here, draw an arc. From here, cut an arc. From here, cut an arc. Okay, and finally, cut 5.8 from here. Cut 5.8 from here. That's D, E, and F. Join. This is going to be a hexagon for y'all. Okay, a hexagon for y'all. Now I have to draw an a circle inscribed inside it. So for this word, for the word inscribed, come on, we have done this in the 5th or the 6th sum. Isn't it going to be the angle bisector? Whenever you come across the word inscribed, it is angle bisector, angle. Now the best part out here is we already have two angles made. Let me take the base angles. Right, students? So take this as the point. Just stretch it approx. Cut an arc. From this point, cut an arc. Yeah, somewhat like this. It'll go. Again, from this, cut an arc. From this, cut an arc. Okay. Where they meet, it's your point O. From here, I'm going to make a smiley. You know what a smiley is. Keep the tip of the rounder out here. Stretch the compass to a certain extent and just make a smiley out here. So keep the tip of the rounder out here, stretch it till AB, make a smiley. From this point, keep the rounder tip out here, stretch it, lump sum, cut an arc. From here, cut an arc. You make a perpendicular. And that's a perpendicular. Final verdict. Keep the rounder tip, the tip of the compass at O, stretch it up till here, draw a circle. Draw a circle. So you're going to have a circle which definitely touches, yeah, all the sides of the circle with this as the center. So again, if I happen to analyze what I've spoken, what I've drawn, first you draw a regular hexagon. 5.8, 120 degrees, cut 5.8, 5.8. 120 degrees, cut 5.8, 5.8, join. Once the hexagon is ready, two angle bisectors where they meet, smiley, perpendicular, smiley, perpendicular, taking that as the radius, draw a circle. Right? So this was my 10th question. Now, from the question numbers 11 to 15, actually construction chapter is over, completed. Listen, we just have these variations. You do not have any more varieties. It's over. Construction chapter on its own, as its own accord, it's completed. Now, we start with sums which are an amalgamation, a combination of locus with construction. So isn't it now, what we're going to see from 11 to 15 and further down the path? It's going to be construction along with locus or loci, right? So now I need to involve a few steps, a few highlights